Hello everyone, today we're going to solve set 7, problems 17 and 18. Problem 17. The diagram is a map of J's local rail network where the dots represent stations and the lines are routes. J wants to visit all the stations, traveling only by train, starting at any station and ending at any station, with no restrictions on which routes are taken. Now, I'm going to put this station as station 1, this as station 2, this as station 3, and this as station 4. Now they're the end point stations. That doesn't mean like it's the end, it's the last station, but it is the station that is at the end. Now, looking at station 1, there are 4 stations from the intersection to station 1. And same for station 2, there are 4 stations on its way. And for station 3, there's only 3 stations. And for station 4, there are only 2 stations from the intersection. Now, because we want to minimize the number of stations that J must go more than once, we don't want to go to station 1 and station 2 in the middle of the course, because that would maximize the number of stations that he has to go twice. So station 1 and station 2 should be the stations that J starts from, or that J should end. So I'm going to just say station 2 as the starting point and station 1 as the finishing point, which means that we're going to station 3 and station 4 in the middle of the course. Now, I'm going to start from station 2, we're moving right, and then we're going to turn right, heading to station 3, because if we go to station 4, we have to come all the way back, and that would be the worst case, and we don't want to do that. So we're going to station 3, and then we have to go back to station 4. Now we're going this station and then this station twice. So we went 2 stations twice until now, and then we're going to station 4, then we're coming back to the station again. So this is our third station that J went twice, and then we're heading to station 1. So this is the route that has the smallest number of stations that J must go to more than once, and he went to 3 stations twice, so D is the correct answer. Problem 18. Which of these statements is true? Now, looking at all the options, 5 to the power of 6 is a key to this question, and there are many ways of calculating the value of 5 to the power of 6, such as like if you multiply 10 and divide it by 2, it's the same as multiplying 5, but the calculation is easier. So for example, like 5 to the power of 3 is 125, and it might take some time to multiply 5 every single time, so you just add a 0 here, and then you're dividing it by 2, and that would be much quicker. And other option is 5 times 6 is just same as the square of 5 cubed, which is the square of 125. And there are many other ways, but for the sake of your time and for convenience, I'm just going to write what the value is. It is 15625. Now looking at every equations, we have a common pattern here. We have 1 plus 5 to the power of 6 minus 1 times n, and n is different for all options. And this means that 1 plus 5 to the power of 6 is 15626 minus n. Now this is the equation for all answer choices. Looking at A, we have 7 as n, and if we subtract 7, we get 15619, which is incorrect. Option B, we have n as 8. So if we subtract 8, then we have 15618, which is true. So B is the correct answer. And you can calculate by yourself of the other options and they will be incorrect. Thank you everyone, and I'll see you again. Bye.